Hello ladies and gentlemen of cyberspace. My name is Phil and I am the webmaster of the website www.ab9il.net. Recently I've received a lot of emails regarding the 15-element Wi-Fi Yagi antenna project. That antenna provides lots of gain and it is an excellent means of getting a strong Wi-Fi signal into your access point and receiving your access point quite strongly, thereby allowing you to get faster connect speeds. People mostly want to know if a shorter version will work as well as the 15 element, and the answer is mostly yes. If you're building an antenna anywhere from about 10 elements through the 15, it all works fine. If you want very, very long-range Wi-Fi connections and you want something a little more performance enhancing than the 15-element antenna, I would recommend that you use the calculator on the website, but go no higher than about 22 to 25 elements. Beyond that, you're doing a lot of work to build an antenna and not getting much more gain and directivity out of it. Today, I am going to walk you through the construction of a somewhat shorter 12-element Wi-Fi Yagi antenna. It'll provide about 11 to 12 dB gain, which is very good. It more than 10 times multiplies your signal strength at a distant location, and it will certainly allow you to receive weak or distant access points very strongly, much more stronger than if you were running a USB Wi-Fi adapter without any external antennas or modifications. There are people out there on large parcels of land, farms, some towns with community Wi-Fi that are using these antennas and getting very, very good results. This 12-element antenna is constructed using simple materials. For example, the boom is simply a length of 3/8 inch square wood. If you're using the metric system, that's about 1 centimeter square on a side. And the wire that we're going to use is a length of number 14 gauge solid copper wire. You only need about a meter or a yard of that wire. You will cut it into short segments for the radiating elements of the antenna. There is going to be a bit left over, so if you make a mistake in measuring and cutting, then you can simply cut another piece that is the proper size. Antenna elements are calculated using the online antenna calculator at ab9il.net. It's on the page wifi6.html in that website. You can see here dimensions for the 12-element Yagi. The reflector element measures about 60.1 millimeters. The driven element measures about 59.03 millimeters. And by the way, I cannot measure or cut that accurately. You see lots of decimal places on here. That's strictly because the computer ran the numbers and that's what it came out with. If you can at least cut within an accuracy of 0.5 millimeter, that should be fine for this antenna. Element number 2, again as a regular dipole element, would measure about 59 millimeters. We're going to feed this antenna using a folded dipole second element. Therefore, we'll have to double this distance, this length, and make it 118 millimeters when we cut the wire, and plus allow a little bit of extra length for spacing between the two parts of this folded dipole. It is essentially the same kind of antenna that is popular for FM radio reception. I want to show you here exactly how we'll determine the lengths for element number 2. Simply take the length for element number 2, the driven element, from the computer calculation, and double it, and then add about a centimeter. We want the two parts of the folded dipole to have about a half a centimeter spacing between them. You'll have a good impedance match, and power will transfer very nicely from your wireless device into the radiating elements of the antenna. Now the antenna boom that we're going to use is again a very small, inexpensive, lightweight piece of wood. This piece is about 15 inches long, and in the metric system it's about 38 centimeters in length. The important thing to remember is that you must drill and mount the antenna elements very, very carefully on this. You don't want the elements to be too close or too far, or cut too long or too short, or the antenna will not perform well. So what I have done on this boom is I have drawn a line precisely down the middle of one side and then put tick marks to represent the locations of each of the antenna elements that we're going to mount on this boom, all the way down to some of these elements that are somewhat closer spaced for the reflector, driven element, first reflector, and all the way down to the far end. It's also cut just a little bit longer than necessary so that I have space here on this end for mounting hardware, and also the wireless adapter itself, which is going to be velcroed or wired to the boom in order to give it some mechanical stability. We have here a set of wire elements that have been pre-measured and pre-cut, starting with reflector element number 1, the driven element, which you can see is about twice as long as it needs to be for a regular dipole, but we're going to fold that over, and I'll show that to you in a few minutes. And then we have element 3 all the way down to element 12, which are known as the director elements of the Yagi antenna. It's very important to remember when cutting these, again, cut accurately, measure accurately, try to keep all of the elements straight, and after you drill holes in the boom and start mounting these, try to center them as precisely as you can. Continuing now with our discussion of the driven element of this antenna, it is once again a folded dipole, cut long, and at this point I am mounting it on the boom. You can see it has been bent on one side. This is 1/2 of the element length that we pulled out of our calculation for element number 2. Officially it's 59.03 millimeters. I'm going to bend this end to match and mate very precisely with this part of the antenna, and this is where the RF will be fed to the antenna. Now, after you have mounted each of the elements in their proper place on the antenna boom and centered them, including carefully bending and mounting the folded dipole driven element, your antenna should look like this. It is almost ready to put into service. All that's necessary is either soldering the center conductor and shield of some coaxial cable to the driven element and running that to your wireless adapter or router, or simply putting a connector on this and using standard connectors and cable, using that to run to your wireless adapter or router, and then you put it into service. There's enough room on the end of the boom for mounting hardware of any kind, anything from Velcro, nylon cable ties to lash it on to a post, or using 90-degree angle brackets and some small screws to attach it to a fixed sturdy support. Anything like that will work. And simply mount this, point it at your access point, and enjoy a signal that is approximately 10 times stronger than what you would have had if you had been using one of those silly little rubber dipole antennas. Thank you for watching, and good luck.